This is the lecture for the assignment on 10.2 through 10.5. I will do separate videos for each section, and they will be embedded always under your assignment tab for that assignment. When I get a video lecture done, I will embed it in there. First, we will go over 10.2. Notice 10.2 vocabulary. On this vocabulary, we see 9 to the negative 1/2 power. That first means we can get rid of that negative exponent by moving it down to the denominator, 1 over 9 to the 1/2. Then, what does a fractional exponent mean? The 2 on the bottom is the index of your radical, meaning the square root of 9 to the first. And the square root of 9 is 3, of course. 1/3 is our answer. And yes, that's a positive number. Number 2, same example. 9 to the negative 1/2 is 1 over 9 to the 1/2, which is 1 over the square root of 9, because that 2 means square root of 9. And that's 1/3, not a whole number. Number 3, a to the negative m over n. To get rid of that negative exponent, move out of the denominator to the numerator. A to the m over n. And so we've got it with a positive exponent. Number 4, when you have an x and an x times each other, no matter what the exponents are, you add those exponents. When you're taking a variable times the same variable, you add the exponents. Just like x squared times x cubed is x to the 5th. You add exponents. But when you have x to any power, and then you've got a power outside your parentheses, the power rule, you multiply the exponents. So in other words, 2/3 would be times 1/5, 2/15. Or the example, x squared to the 3rd power is x to the 6th. Then, when we have an x over an x, we're of course dividing. You subtract 2/3 minus 1/5. You subtract, or like the example, x to the 6th over x squared is x to the 6 minus 2, x to the 4th. Then using these concepts on 1 through 40, okay, I've done the even, and remember you can pause this film and write things down. And it takes a long time to upload, so that's why I try to make them shorter. 49 to the 1/2 is the first one. Number 2, though, is 64 to the 1/3. That 3 is your index of 64. So cube root is 64, which is 4, because 4 times 4 times 4 is 64. 3, 27 to the 1/3. 4 is 8 to the 1/3, meaning cube root of 8, 2. 5 is 1/16 to the 1/4 power. That 4 would be your index on that one. Just like on number 6 here, 1 over 64 to the 1/2, the 2 is your index, meaning square root of 1 over 64. And the square root of a fraction, take square root of 1, which is 1, square root of 64, 8. 7, 169 to the 1/2 power. 8, 81 to the 1/4. The 4 is your index. 4th root of 81, which is 3, because of 3 times 3 times 3 times 3 is 81. Then, I did do number 9, even though it was an odd question, because it's a little confusing. 2m to the 1/3. That 1/3 is only for the m. So the 2 is not inside the radical. The 3 on the 1/3 is the index, cube root of m. The exponent for the 2 was a 1. But number 10, because of parentheses, 2m is inside the parentheses to the 1/3. Because of the parentheses, it is the cube root of the whole thing. 11, 9x to the 4th to the 1/2 power. I've started that. Means the 2 goes here, square root of 9x to the 4th, and then you finish it by taking the square root of each. Number 12, 16x to the 8th to the 1/3 power to the 1/2 power, excuse me, means square root of 16x to the 8th. Square root of 16 is 4 on a number, but on an exponent, you take your index, which is 2, divided into 8, which is 4. So 4 from the square root of 16, and 8 divided by 2 on the exponent, 4. So 4x to the 4th is our answer. Number 13, negative 27 to the 1/3. Negative 27 is inside the parentheses, so it will be inside the radical. But on number 14, negative 64 to the 1/2, the negative is not inside the radical. Inside parentheses, so the negative is not inside the radical. So it's the negative square root of 64, negative 8. 16, on this one, no parentheses, so the negative would not be in the radical. The 16 would be in the radical, and it would be the 4th root of 16. 16, you've got parentheses, so the negative 32 is inside the radical. 5th root of negative 32 is negative 2, because I show as it works out here. Number 17, now we start working with having a numerator on the fraction besides 1. 16 to the 3/4 for 17. 18, 4 to the 5/2. First, do the denominator of your fractional exponent. 2 means square root of 4, which is 2. Then work with the numerator, the 5. 2 to the 5th. 2 times 2, 5 times, is 32. 19, negative 64 to the 2/3. 20, negative 8 in parentheses, just like 19 was, to the 4/3. So since negative 8 is in parentheses, goes inside the radical, so cube root of negative 8, because we start with the denominator, cube root of negative 8 is negative 2. Then we take that negative 2 times itself 4 times, 16. 21, negative 16 is in parentheses, to the 3/4 power. 22, negative 9 to the 3/2 power. The negative 9 is in parentheses, so negative 9 goes inside the radical. And then our denominator of our fractional exponent was a 2, which is an even index. You cannot take an even index or an even root of a negative number, so it's not real. 23, I did it because I wanted you to understand it. 2x is inside parentheses to the 3/5. So that means you take the 5th root of 2x cubed, because it goes inside the radical. Then 2x cubed, 2 times 2 times 2 is 8, x cubed. 5, the 5th root of 8x cubed. But on 24, no parentheses, so the 3/5 is only for the x. 2 is outside the radical, 5th root of x cubed is your answer. 25, a quantity, 7x plus 2 to the 2/3 power. 26, x minus 4, a quantity, to the 3/4 power. So again, 4 is your index, and x minus 3, quantity cubed, goes under the radical. 27, 16 over 9 to the 3/2 power. 16 over 9 is in parentheses. 28, 49 over 25 in parentheses to the 3/2 power. So again, we take the denominator. The 2 means square root of 49 over 25. Square root of 49, 7. Square root of 25, 5. So 7 over 5, quantity cubed. And 7 times 7 times 7, 343, over 5 times 5 times 5, 125. Number 29, 8 to the negative 4/3. Negative exponents. So I'm going to show you what to do with negative fractional exponents. 30, 64 to the negative 2/3. First, get rid of the negative exponent. And as we know, to get rid of a negative exponent, you move it to the other part of the fraction. 1 over 64 to the 2/3. Then we start working with the fractional exponent, 2/3. The 3, the denominator, means cube root of 64, 4, so we have 1/4 so far. And then the 2, the numerator of the fractional exponent, we square that 4, 1 over 16. 31, negative 64 in parentheses to the negative 2/3. 32, negative 8 in parentheses to the negative 4/3. Get rid of the negative exponent, move it to the denominator. Then do the cube root first, the denominator, cube root of 8 is, cube root of negative 8, I forgot it was in parentheses and I kind of crowded it in there, negative 2. Then negative 2 times itself 4 times 4 negatives, so it's positive 16. 33, negative 4 in parentheses to the negative 3/2. 34, negative 16 to the negative 5/4. Get rid of the negative exponent, move it to the other part of the fraction. Then work with the denominator of the fractional exponent, the 4th root of negative 16. 4 is an even number, cannot take an even root of a negative number, so not real. 35, x to the negative 1/4. 36, y to the negative 1/6. So get rid of the negative exponent, move it to the denominator, 1 over y to the 1/6. Then 1 over the 6th root of y. 37, we have 1 over a to the negative 2/3. 38, 1 over n to the negative 8/9. So we move it out of the denominator to the numerator, gets rid of the negative exponent, n to the 8/9. Then, as a radical, the 9 is your index, the 9th root of n to the 8th. Then, 39, 5 over 7, x to the negative 3/4. 5 didn't have an exponent, so it's understood to be 5 to the 1st. 7 didn't have an exponent, so understood to be 7 to the 1st. The x is the only one with the negative exponent. 40, 2 over 3y to the negative 5/7. 2 didn't have an exponent, so it's 1 as its exponent. 3 didn't have an exponent, so it's 1 as its exponent. So we move up the y only. 2 and 3 had 1 as their exponent. No negative exponents. They don't move. So 2y to the 5/7 over 3. Then, as a radical, 2 is not in the radical because its exponent was 1. 7th root of y to the 5th, taking care of this, and then 3 in the denominator.